Here is a rigid body dynamics problem from JEST 2024. We are given a cylindrical rigid block which has principal moment of inertia I about symmetry axis. This is the symmetry axis, Z axis. I along the symmetry axis is IZ is equal to I, and we are told that the principal moments of inertia are 2I about each of the perpendicular axes, which means Ix, this is x-axis, Ix is equal to 2I, and also Iy is equal to, this is y-axis, Iy is equal to 2I. At some instant, the components of angular momentum about the center of mass in the body fixed principal axis frame is L with L greater than 0. That is, angular momentum L is equal to Li plus Lj cap plus Lk cap, because these are the components. This is x component, this is y component, this is z component of angular momentum. Now we are asked to find the cosine of the angle between the angular momentum and the angular velocity. Now we can use the definition of dot product here for finding the angle between any two vectors. If there is a vector A and there is another vector B, then the angle between them is theta, then cos theta is equal to A dot B divided by magnitude of A times magnitude of B. This is how we define the angle between two vectors. Therefore, we can write cos theta is equal to the angle between angular momentum and angular velocity is equal to L dot omega. Omega is angular velocity divided by magnitude of angular momentum times magnitude of angular velocity. Now to get angular velocity, we can use the relation L is equal to I omega. Here I is the inertia tensor, which is equal to Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz. The diagonal terms Ixx, Iyy, Izz, these are called moment of inertias, and the off diagonal terms, all of these off diagonal terms, they are called product of inertias. Now these products of inertia and moments of inertia represent the resistance or inertia to the rotation of rotating objects. Now if we choose a principal axis coordinate system, then I will be diagonal. I will be equal to I principal. Like in this problem, we have principal moments of inertia. In that case, I will be equal to Ix, Iy, Iz. All the other non-diagonal terms will be 0. And these values of diagonal elements, these are principal moments of inertia. So when we are in principal axis coordinate system, then we have Lx, Ly, Lz equal to Ix, Iy, Iz 0 0 0 0 0 0 times omega x, omega y, omega z. So this is L is equal to I omega in the matrix form, when we write it, we will be writing it like this. And therefore from here we can say Lx is equal to Ix omega x, Ly is equal to Iy omega y, Lz is equal to Iz omega z. Now Ix is equal to Ix is equal to 2i, Iy is equal to 2i, and Iz is I. And the value of Lx is L, Ly is also L, and Lz is also L. Therefore if we put these things, we will get omega x is equal to Lx divided by Ix, which is L divided by 2i. Omega y is equal to Ly divided by Iy, which is L divided by 2i. And omega z is equal to Lz divided by Iz, which is L divided by I. Therefore angular velocity vector, this is equal to L divided by 2i I cap plus L divided by 2i j cap plus L divided by 2i k cap. Now if any one of you are curious or don't know how Ixx, Iyy, Izz, Ixy, Iyz, Ixz, all of these terms are defined, then you can look at this page and note this down. In the inertia tensor, we have Ixx, Ixy, Ixz. All of these terms are defined like this. Integral dm y square plus z square, this is how we define Ixx. And also you can note that Ixy is equal to Iyx and Ixz is equal to Izx. So this matrix, the inertia tensor, it is a real and symmetric matrix. Or you can say this is Hermitian matrix, because real symmetric matrices are Hermitian. And for Hermitian matrices, eigenvalues are real and eigenvectors are orthogonal. So these points you can note it down if you want. Now let's continue the calculation. Cos theta is equal to cosine of angle between angular velocity and angular momentum is equal to L dot omega divided by magnitude of L vector times magnitude of omega vector. This is equal to L vector is Li plus Lj plus Lk cap dot omega vector is, we found the omega vector here, which is L by 2i I cap plus L by 2i j cap L by 2i j cap plus sorry, I made a mistake here. This should be L by, here omega z is L by I, but I put L by 2i here, so this is incorrect. There is only L by I. Omega z is L by I. Therefore we will have L by 2i I cap plus L by 2i j cap plus L by I k cap divided by magnitude of L vector is root of L square plus L square plus L square, which is root of 3L square, times magnitude of angular velocity is L by 2i the whole square, which is L square by 4i square plus L by 2i the whole square, which is L square by 4i square plus L by I the whole square, which is L square by I square. Therefore this is equal to cos theta is equal to L square by 2i plus L square by 2i plus L square by I divided by root of 3L square times root of 6L square by 4I square this is equal to 4L square by 2I divided by root of 18 by 4 L raised to 4 divided by I square. This is equal to 2L square by I divided by root of 9 by 2 L raised to 4 by I square, which is equal to L square and L raised to 4 under root cancels, I and root of I square cancels, remaining is 2 root 2 divided by root 9, which is 3. Therefore the correct option here is option C. Option C is the correct answer.